Welcome to homework.
We're asked to prove that the principle of mathematical induction and strong induction are equivalent. That is, each can be shown to be valid from the other. So, first, let's assume that the principle of mathematical induction is valid. So, assume that P0 and P0 and P1 and P2 all the way up to Pk are true for some k greater than or equal to 0. Okay, so let's assume that P0 is true and that P0 intersects Pk implies Pk plus 1 for all positive integers k. So now let Pk be true and assume for the sake of contradiction that Pk plus 1 is false. Then it follows that P0 or P1 or up to or Pk is false. Or okay, now let I be the smallest. It can't be P0, it has to be P1 because P0 we know is true. So let I be the smallest integer where I lies between 0 and less than k. Again, we know that Pk is true such that Pi is false. We then note that P0 through Pi minus 1 are all true. And P0 and P1 and Pi minus 1 implies Pi is true. This implies that Pi must be true. Of course, this is a contradiction. So the assumption that pk plus 1 was false is incorrect. So it follows that pk plus 1 is true. And then this implies that pk implies pk plus 1. And so for all positive integers, and so it follows that Pn is going to be true for all positive integers n by the principle of mathematical induction. So principle of strong induction is valid. So that was one way. Now let's suppose that the principle of strong induction is valid. We want to prove that the principle of mathematical induction is then valid. So we have that assume that P0 and pk implies pk plus 1 for all k, and now suppose that P0, P1, all the way up through pk are true. And since pk is true, it follows that pk plus 1 is true. And so, by the principle of strong induction, it follows that Pn is true for all positive integers n. Okay, before we do that, actually, what we've actually shown here is that so P0 and P1 and up to pk implies pk plus 1 for all k. And so now, by the principle of strong induction, it follows that Pn is true for all n, and so it follows the principle of mathematical induction is valid.